Hello friends, welcome to Mind Your Math by Kona YouTube channel. This is yours Kona Karan Reddy. Today in this video, let us discuss the problems from exercise 12.2 of chapter 12 of 8th class mathematics. The chapter name is Exponents and Powers. Let us do problem number 1. Express the following numbers in standard form. First of all, what is standard form means? Standard form means the number, if it is written in the form of a times 10 to the power of b, here a should be in between 1 and 10, including 1 and excluding 10, and b could be any integer. Then that is said to be in standard form. For example, 4.7 into 10 to the power of 5. This is in standard form. Suppose if I write 1 times 10 to the power of minus 9, it is also in standard form. Suppose if I write 10 times 10 to the power of 4, this is not in standard form. Why? Because this value 10, this must be in between 1 and 10, including 1 and excluding 10. That means we can write 1, but we can't write 10. The number must be in between 1 and 10, including 1 and excluding 10. Then that is said to be in standard form. Now let us see first one. Here we have some zeros and then 85. So we need to write this number as 8.5 times 10 to the power of something. Now here if you write 8.5, then 10 to the power of how much we need to write? Just simply suppose here is this point. Then how many digits we are moving the point? The point is to be moved to right. And how many digits? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 digits we need to move. If we move like that, then we need to write negative 12. That means if we move the point from left to right, we need to write in the exponent negative. Right, let us go to second problem. That is equal to, here we have some zeros and then 942 we have. So where should be the point? Here we have 942. Then we need to write like 9.42, so that will be in between 1 and 10. For that we need to move the point to right. How many places? Let us put the point here suppose. Then how many places we need to move? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that should be times 10 to the power of negative 12. Like that we need to write. Then third one. So here we have, there is no decimal point. Then how can you write and where can you write decimal point? We can write easily like this, 0.0, like this we can write. So that means suppose we have 4, we can write 4 as 4.0. Suppose we have 123, we can write this one as 123.0. Like that we can write. Similarly here also we can write 0.0 like that. This is equal to. Now to write in standard form, this should be, here we have 602. We need to write like 6.02 times 10 to the power of. So here how many places we need to move? Here we need to move left. How many places we need to move? Let us count. So here we need to put the point, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15 places we need to move to left. So we write 10 to the power of 15. Next, this is equal to, here we have 837. So we need to write like 8.37 times. So here if you put point here 8.37, we need to move the point right. How many places? 1, 2, 3, 4, 5, 6, 7, 8, 9 places. So we need to write 10 to the power of negative 9. Next, the last one. Here there is no decimal point. We can write like this, 0.0 like that. Okay, now here we have a point. So here 3186 we have. So we need to write 3.186, so that will be in between 1 and 10. So here we need to put the point, you see here. Then how many places we need to move? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 places. So we can write times 10 to the power of 10. If we move to the left, then we need to write positive exponent. If we move to the right, then we need to write negative exponent. Right. Let us go to the next problem. Express the following numbers in usual form. Right. This is equal to 3.02 into 10 to the power of negative 6. We can write this one as 3.02 divided by 10 to the power of 6. This is equal to, we can write, here you see 3.02 we have, then 10 to the power of 6 we have. So we need to move this point to left. How many? 6 digits or 6 places. Suppose we have 542 divided by 10. We write this one as 54.2. Suppose we have 542 divided by 100. We write this one as 5.42. That means here we have how many? 2 zeros, and then we need to move. Assume that here we have decimal point like this. Then we need to move here. That means 2 units left. Like that we need to put the point like 5.42. So that means how many zeros we have, we need to count. Then move the decimal point left. In the same way here also we write like 3.02 here. Let us ignore the point. Then before 3 let us write zeros like this. How many zeros we can write? We can write any number of zeros, no problem with that. So here 10 power 6 means we need to move the decimal point 6 places left. Where is that now? Here at 3. After 3 we have. So from here we need to move 6 units. 1, 2, 3, 4, 5, 6. So here we need to move. That means here we need to put the decimal point. So the answer will be, this is equal to 0.12345 zeros, 0, 0, 0, 0, 0, then 302. That is the answer for this question. Next, second one. 4.5 times 10 to the power of 4. This is equal to, as the exponent is positive, we need to move this point right side. How many places? 4 places. Suppose we have 4, 5. Suppose 0, 0, 0, 0, 0. Suppose we write like this. Where is the point now? Between 4 and 5. So here. From this we need to move how many digits? 1, 2, 3, 4. That means here we need to put the point. Like this. So this will be 45000. That's it. After the point we have zeros, we can ignore them. So 45,000 we will get. Now this is equal to 3 into 10 to the power of negative 8 we have. So before 3 we need to write zeros. 1, 2, 3, 4, 5, 6, 7, 8. So here negative 8 we have. 3 means we can take that one as 3.0. How many units we need to move left? 8 units. So here, suppose here is the point. 1, 2, 3, 4, 5, 6, 7, 8. So that means here we can put the point. Next, fourth one. 1.0001 times 10 to the power of 9. Here, as the exponent is positive, we need to move the point right side. How many digits? 9 digits. Here 10001 we have. So how many digits we need to move? 9 digits or 9 places. Here already we have 1, 2, 3, 4 places we have. So 1, 2, 3, 4. The remaining 5 we write them as zeros. 1, 2, 3, 4, 5. That's it. So that the point will be moved to 1, 2, 3, 4, 5, 6, 7, 8, 9 places right. Okay. Now let us go to fifth one. This is equal to 5.8 times 10 to the power of 12. As the exponent is positive, let us move the point right side. How many places? 12 places. There is already one place. So we need to write 11 zeros. So we can write 5, 8, 11 zeros we need to write. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That's it. Next, sixth one. This is equal to, here 10 to the power of 6, positive exponent we have. So we need to move the point right side. How many digits? 6 digits. There are already 1, 2, 3, 4, 5 places. We need to write just 1 0. So 3, 6, 1, 4, 9, 2, 0. That's it. Let us go to the next question. Express the number appearing in the following statements in standard form. Standard form means, I already told you, standard form means a number between 1 and 10, a number between 1 and 10 including 1 and excluding 10 times 10 to the power of some value. That value must be integer. That means the exponent of 10 must be integer. First one, 1 micron is equal to 1 by 1,000,000 meters. We can write 1 by 10 as that is equal to 10 to the power of negative 1. 1 by 100 means that is 10 to the power of negative 2. How many zeros we have? 2 zeros we have. So we got negative 2. Here 1 0 we have. In the exponent we have 1 negative 1. Similarly, suppose we have 1 by 1000. Then we write this one as 10 to the power of negative 3. So 1, 2, 3 zeros we have. We got negative 3 in the exponent. In the same way here also we have 6 zeros. So we write 10 to the power of negative 6. We can write this one as 1 times 10 to the power of negative 6 meter. This is in standard form. Now second one. Charge of the electron, that is we have some number coulomb. So we need to move decimal point right, so that here we have 16. We can write that one as 1.6 times 10 to the power of. So here if you put point here, how many digits we need to move the point, how many places we need to move? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19 places we need to move right side. 19 places we need to move right side. So that will be minus 19. That's it. Next, third one. Size of a bacteria is 0 point something we have. So here 5 we have. So we can write 5.0 or 5 times. So how many digits or how many places we need to move? 1, 2, 3, 4, 5, 6, 7 places we need to move. So times 10 to the power of negative 7 we can write. Next, fourth one. Here we have 1275. These are said to be significant figures actually. Okay, 1275 we have. So we can write this one as 1.275. So that it will be in between 1 and 10 times. Where should we move the point here? Between 1 and 2. So that means 1, 2, 3, 4, 5 digits we need to move. So that means we can write 10 to the power of negative 5. Then fifth one. Thickness of a thick paper is 0.07 millimeter. So 0.07 can be written as 7 into 10 to the power of negative 2. So this is millimeter. The previous one, fourth one is in meters. And the second one is in coulombs. Third one is in meters. We need to write those units also. Right. Let us go to the next problem. In a stack, there are 5 books, each of thickness 20 millimeter, and 5 paper sheets, each of thickness 0.016 millimeter. What is the total thickness of the stack? So here we have how many books? 5 books, each of thickness 20 millimeter. So here let us write number of books. Number of books. That is equal to how many? 5. So thickness of each book. Thickness of each book. That is equal to how much? 20 millimeter. Therefore, thickness of 5 books, that will be equal to 5 times 20 mm. So that will be equal to 20 times 5. That will be 100 millimeters. Now let us take the paper sheets. How many paper sheets are there? 5 paper sheets. So number of paper sheets. Number of paper sheets. That is equal to how many? 5. Thickness of each paper. That is equal to how much? 0.016 millimeter. Therefore, thickness of 5 papers, thickness of 5 papers will be equal to 5 times 0.016 millimeter. So if we multiply these two, we will get 16 times 5 is 80. But after the decimal point, we have 3 digits. So here in the result also, there must be 3 digits. There is only 2 digits. So put 0 here and put point here and then write 0 here. So 0.080. That is the thickness of 5 papers. Therefore, total thickness of the stack that will be equal to thickness of 5 books and thickness of 5 papers. So that will be 100 mm plus thickness of 5 papers, that is 0.080 mm. So that will be 0.080 mm. So if we add these two, we will get 100.080 mm, or we can write 100.08 mm. This is the thickness of the total stack. With this, exercise 12.2 is completed. If you like my explanation, please subscribe my channel. Thank you one and all. Yours Kona Kiran Reddy.